Hi everyone, thank you so much for coming to this lesson. So in this lesson we're going to be covering parametric equations. So the learning objectives is to be able to use parametric equations of curves and to be able to switch between Cartesian and parametric forms. So for this lesson it'll be really useful if you review the topics on circle geometry, straight line graphs and also just drawing graphs in general. So make sure you review that before listening to this video. So like always, there'll be timestamps in the description of the video, so feel free to skip to any parts you want to. So let's get started. The first thing is you need to know what a parametric equation actually is. So normally when you have curves and equation, you would see them with x and y, so you could have y equals 2x plus 1, for example. But what a parametric equation does is it splits the x and y variables of the curve into two and defines these two in terms of another variable. So for example, this is an example of a parametric equation, and we have x equals t plus 1 and y equals t squared minus 1. And the parametric equation has just defined these two x and y in terms of a third variable t. And this t is what you would call your parameter. So if you were to plot this graph, you just plot it on a normal x and y axis, like you would normally do. But you could draw a table like this, and you want to find values of x and y for different values of t. So let's say you had t was 0, so then your x would be 1, then your y would be 0 minus, so your y would be minus 1. Let's say you had 1, your x would be 2, and your y would be 1 minus 1, so it would be 0. And if you had 2, your x would be 3, and your y would be 2 squared is 4 minus 1 is just 3. And if we did the negative versions of that, let's say we had minus 1, then your x would be minus 1 plus 1, that's just 0. And your y would be minus 1 squared minus 1, which is just 0 as well. And then if you had minus 2, you'd have minus 2 plus 1, which is minus 1. Then you'd have 4 minus 1, so you just have 3. Then if we were to plot some of these coordinates, so we have a 0, 0 here, you have 1 minus 1, so you have 1 here minus 1, so it'd be somewhere here. We have 2, 0, so we have here, which is 2. And then we also have minus 1 and 3, like this. So let's try another value. Let's say we have 3. Your x would be 4, and then your y would be 9 minus 1, 8. So then you would have a y value like somewhere here, and 3 and 8. So you kind of just have a curve. You join the points, you have like a curve like this. So basically these parametric equations here is just representing a normal quadratic curve. So that's just an overview of what parametric equations are and how you can draw a curve from them. So if we try an example of how we could actually use parametric equations to find different values of x and y at different coordinates. So if you want to try this question for yourself, and then you can come back with the solution. So we have x equals 2t minus 3, and we have y equals 1 over 3t. And for the first bit, we want to try and find the values of x and y that correspond to t being equal to 4. So what you do is you just plug t equals 4 to both of these. So you'd have x is equal to 2 times 4 minus 3, which is 8 minus 3, which is just 5. You'd have 1 is equal to 1 over 3 times 4, which is just 1 over 12. And then for the next bit, you want to find the value of t that corresponds to y is being equal to 9. So you just plug in 9 in this bit and find t. So you just get 9 is equal to 1 over 3t. And if you multiply both sides by 3t and then divide by 9, you get 3t is equal to 1 over 9. So then t is just equal to 3. And then finally, if you wanted to try and find what the value of y would be when x is equal to minus 15, you would just, for this one, what you do is you would try and find the value of t, and then you can plug that in for the equation of y. So then if we do minus 15 is equal to 2t minus 3, so we want to find the value of t. So we add 3 to both sides to get minus 12 is equal to 2t, so then t is equal to 6. And if we plug that into this equation to find y, you would get y is equal to 1 over 3 times 6. So that means y is just equal to 1 over 18. So that's just how you can use parametric equations to find some coordinates. So one last thing you need to know about parametric and curves is how you could use parametric equations to represent circles. So if you have a circle with centre AB and radius r, then the parametric equations would just be x is equal to r cos theta plus a, and y is equal to r sine theta plus b. So just memorize this, and that's just your parametric equations for the equation of a circle. So let's say we have, for example, let's say we have x is equal to 3 cos theta plus 1 and y equals 3 cos theta plus 2. Our radius is just what's in front of the cos theta or sine theta, so our radius is just 3. And then our centre would just be, so our A is equal to 1 and our B is equal to 2, so then it's just equal to 1, 2. So then if we drew this, we just have 1 here, 2 here, we have x and y, and radius 3, so it's across both axes, it would be something like that. Well, kind of a rough sketch with the radius being 3. So this would be 5, this would be minus 2, this would be 4, and this would be minus 1. So now if we move on to an exam style question, so feel free to pause the video and try it out for yourself. So we have x equals 4t squared minus 1 and y equals t cubed minus t. So the first thing we want to do is we want to find the coordinates of the points where the graph crosses the x-axis. So to do that, whenever it crosses the x-axis, y will always be 0. So we could just plug in y equals 0 here to find the value of t, and then we can plug the values of t back into x to find the x coordinate. So let's do that. So we'll have 0 is equal to t cubed minus t, and then if we factorize out t, we'd get t squared minus 1. So then we get t is equal to 1, and then if we have t squared is equal to 1, and then t squared is equal to plus or minus 1. So those are the 3 values of t we have. And then if we plug these back into x, we would have x is equal to 4 times 0 squared minus 1, which is just minus 1. X is equal to 4 times 1 squared minus 1, so that's just 4 minus 1, which is 3. And then we have x is equal to 4 times minus 1 squared minus 1. It will be the same as that, that will just be 3. So then the coordinates of the points where it crosses the x-axis is just at minus 1 and 0 and 3 and 0. So that's the answer to part A. So now if we move on to part B, and we want to find the coordinates of the points where the graph crosses the line 8y is equal to 3x plus 3. So to do this, it may look a little bit confusing at first, you may not know what to do, but all you have to do is you just have to plug in the values, this value of y into here and this value of x into here, and you just solve that to find values of t, which you can then plug back in to get the x and y coordinates. So let's try that. So we'd have 8, and then we'd have t cubed minus t, and that's equal to 3 times 4t squared minus 1 plus 3, and then if we expand the brackets, we'd get 8t cubed minus 8t, and that's equal to 12t squared minus 3 plus 3. Then we've rearranged it to have all on one side, and that is equal to 0. We would have 8t cubed minus 12t squared minus 8t, and and that would just be equal to 0, as minus 3 and plus 3 would cancel out. So if we factorise, we can take out 4t, and then we would have 2t squared minus 3t minus 2 equals 0. Then we can factorise this out further, and then we would get 2t plus 1. So we can factorise this out further, and we'll get 4t, 2t plus 1, and t minus 2 equals 0. And that would be, so then we'll solve that to get values of t as t equals 0, t is equal to minus a half, and t is equal to 2. So then we can plug these three values of t back into these equations. So for t equals 0, we would have x is equal to 4 times 0 squared minus 1, so that would just be minus 1. Y would be 0 cubed minus 0, so that's just 0. And then if we plug in t equals minus a half to both, we will get x is equal to 4 times minus a half squared minus 1, and that would just be equal to 0. Then we would have y is equal to minus a half cubed minus a half, and that would just be equal to 3 over 8. So you can always check these on your calculator. And then for t is equal to 2, you would have x is equal to 4 times 2t squared minus 1, and that would just be equal to 15, and you'd have y is 2 cubed minus 2, and that would just be equal to 8 minus 2, so that would just be equal to 6. So then the three coordinates you would have as your solution would be minus 1, 0, 0, and 3 over 8, and 15, and 6. So that is how you would solve this question. So whenever you have a question like this, you just plug in the values you know to try find a value of t, which you can then sub into another equation. So the last bit which we are going to cover is going to be able to switch between Cartesian and parametric forms. So remember, Cartesian forms are just an equation in terms of x and y. So the general way to do this is you want to rearrange one of your parametric equations in terms of t, and then you want to plug that t into your other equation. So let's say we have this example with x is equal to 2t minus 3 and y equals 1 over 3t. What you want to do is, so we want to rearrange, so let's rearrange this equation to get an equation in terms of t. So if we add 3 to each side, you get x plus 3 is equal to 2t. And if we divide both sides by 2, we'd get x plus 3 over t is equal to t. X plus 3 over 2 is equal to t. And then we can just plug this value for t, what we got, into this equation for y. So then we would just have y is equal to 1 over 3 times x plus 3 over 2. And that's just equal to 1 over x plus, so we would just times the numerator by 3 here, so you get 3x plus 9 over 2. And then if to get rid of this, you want to multiply both the numerator and the denominator by 2. So then that would be equal to 2 over 3x plus 9. So that is what your y, and therefore you have an equation y is equal to 2 over 3x plus 9, and that's your Cartesian equation. So yeah, just you rearrange to get an equation in terms of t, and then you just sub that term into the other equation and just rearrange so you have y equals something in terms of x. So if we try a more complicated example here using trig identities, so if you've forgotten your trig identities, make sure you review that lesson first and then come back to this. So if you want to pause the video and try it for yourself and then come back for the solution. So we have x equals 1 plus sine theta and y is equal to 1 minus cos 2 theta. And we want to try and make this into the form y equals f of x. So to do this, we want to use a trigonometric identity, a trig identity, to try and have sine theta in both, as that will make our rearranging a lot, and then summing back in a lot easier. So if you remember their identity, we have cos 2 theta, that's just equal to 1 minus 2 sine squared theta. So again, if you don't remember that, make sure you go over that lesson just to make sure. So then you can just plug that back into y. So then you would get y is equal to 1 minus 2 sine squared theta, which is just 2 sine squared theta. So then now we can just we have sine theta here, so we can just rearrange this equation, and we would get x minus 1 is equal to sine theta, and then we can just plug in x minus 1 back into this y equation. So then we would get y is equal to 2 times x minus 1 squared. And yeah, you can just leave it like this, or we can expand it. So we would get 2 times x squared minus 2x plus 1, which is just equal to 2x squared minus 4x plus 2. And that's the answer. So the tricky bit here was just remembering your trig identity and subbing that into your y equation. So you have both parametric equations in terms of sine theta. And then we can just rearrange, and then because we have sine theta in both, we rearrange this equation to get sine theta in terms of x, and then we just sub that back into y, so we would have an equation y in terms of x. So thank you everyone, hopefully you found that lesson useful. So just to sum up, we learnt how to use parametric equations to draw curves and also to find different x and y coordinates, and then we also learnt how to switch between Cartesian and parametric forms. So make sure you do some practice questions to make sure you fully understood everything we've covered. But yeah, thank you.